Hey guys, so this is going to be me collecting the data for the calcium and magnesium EDTA titrations. So um, in the burette, I currently have an EDTA solution that I weighed out about 0.3 grams into a 250 milliliter volumetric flask, filled to the mark, swirled for a good period of time until it dissolved. And then this first set of titrations, we're going to figure out the total amount of calcium and magnesium that are in the water. Right? EDTA, as Dr. Beth has talked about in lecture, will bind to a whole slew of metal ions in solution, but the sample that we have has specifically calcium and magnesium in them. Right. So in here, I have put ammonia buffer to buffer the pH of the titration solution to around 10. Some Ariachrome black tea indicator, which is what's causing this solution to be this sort of reddish wine red hue. And then 10 milliliters of the magnesium and calcium sample. And then I added a little bit extra DI water just to give the solution some depth, right? So initially here, there isn't much of a color change to the solution. It kind of stays this red, but if you look where the stream is hitting, you're starting to see sort of a blue, sort of, I guess, hurricane shape showing up, right? So initially, the EDTA, the reason we don't see a color change is it's reacting with the free calcium and magnesiums that are in solution. Ariachrome black tea, when bound to such metal ions, appears sort of this wine red color. The indicator when unbound is just blue in solution, right? So the EDTA is first reacting with the free calcium and magnesiums in solution, and then once those run out, it will start displacing the bound indicator. And so we sort of start the titration as red. As I displace more and more blue, the solution starts to look purple-ish, right? And then the end point that I'm looking for is when the solution is just entirely blue, right? That means we have no more bound indicator, right? So here we see it started to turning kind of purple, and then this looks kind of blue, right? So at this point, I think I have an endpoint where all of the calcium and magnesiums are now bound to EDTA. There are no longer free calciums in solution. I'm pointing out the small drop that's on the end of my burette that I'm tapping and rinsing in. But I think at this point I have the endpoint. Every EDTA that I've added has reacted and formed a complex with a calcium or magnesium ion in solution, and all of the Ariachrome black tea indicator is free floating. And I'm not sure, I was making some hand gestures here, I'm not sure if I'm actually at the endpoint yet, because this is the first titration. So I'm recording this volume really quick, and you'll notice I've let the solution completely settle down from my swirling. It's now a nice, just still water. So I'm going to add a drop and watch very closely where the drop lands to see if I'm done, right? If the drop lands and my blue changes to a more blue, then I'm not actually blue yet. I'm still in the purple range. So I don't see anything. So the previous point was good, which is what I've written down on the sheet of paper. So I've over titrated here, but I wrote down what the endpoint actually was before I screwed it up, right? So this is still a good titration to keep. I'm trying to show the sort of blue hue here. But yeah, so that's one titration down. I have to refill the burette here because that took, I think, about 30 milliliters. All of the data that I collect will be in an Excel sheet for you guys to use, right? So but yeah, each of these Erlenmeyer flasks was filled with 10 milliliters of the calcium and magnesium water sample, a bit of ammonia buffer into each of them to drive the pH to 10, allowing for this reaction to happen in a reliable fashion, and then some Ariachrome black tea. Right? So recording my starting point volume here. So I'm going to do these 3 titrations. I'm pulling over the first titration just as a reference for me, right? And so we can see the stark contrast between the wine red I ended up with and then the sort of deep blue color at the end point, right? And if you're looking where the stream is landing, there isn't any color change initially, right? the EDTA is landing and it's immediately reacting, or very quickly reacting with calcium and magnesiums that are in the water. And so I don't see any significant color change to the solution for about 20 milliliters. So now you kind of are starting to see some purpley hues start to show up. So I'm going to slow it down. I'm going to start going to quicker drops. And swirling constantly while I'm doing, I think, about a drop a second here. So I'm gonna try to get a camera behind, or a light behind this, so you guys can sort of see the color. I realized that the solutions were quite dark as I was recording, so I was sort of struggling with this. But I needed them to be dark so that I could see a significant color change in them. Right, so this is still pretty wine red. Apologize for the lens flares. It's like a sweet Star Wars movie. All right, so you can see where the drops are landing. They're starting to get little blue pools in this sort of red solution. Right, so I'm getting pretty close to the end point here. Solution's still pretty red though. It stays red for quite a while and then starts going to kind of a maroon and then purple. So now we're at like purple, so I'm getting really close to the end point. Right. Right, and it looks purple because I mean, think back from like art class, right? If you're talking about something that is blue in color and something that is red in color, you mix those two together. When I have about half of the richrome black tea bound and half unbound, it's purple. So here I think I'm close to the endpoint, so I'm bringing it over. We can clearly see I'm not quite there yet. It's still got quite a bit of purple to it. Right? I'm trying to give you guys a better angle of this. Right? Very obvious, the one on the right is still very much purple, where the endpoint that I'm looking for is distinctly blue. Right? So I think I'm just going to add another drop or two here. To get to the endpoint, I'm very close. Right? So notice I have a white piece of paper underneath this thing, so I can try to get subtle color differences as I'm adding. So I'm doing a drop every 3 or so seconds here, really slow. I think I'm almost there. I'm gonna tap in the tip of my burette, rinse everything down to the bottom, bring this up for comparison, and I think we're there. Right. I'm going to do the same technique I did in the previous trial, so I'm going to record what my endpoint is at the moment, and I think I add another test drop to see. So, I sort of let the solution sort of calm down, sort of just be a flat, still surface, and then I add a drop just to see, is there a color change? If not, hey, that previous volume I recorded was my endpoint. Right. This is a really sort of useful strategy when you're trying to go for sort of more subtle color changes. Right, for the phenolphthalein titrations you guys did earlier in the semester, it's very easy to see the endpoint. It's colorless to a very faint pink, right? It's no color to color. That's an easy transition. Whereas going from red to purple to blue is kind of a gradient that's hard to tell when you're finished, sort of like the bromocresol green titrations that you guys did earlier in the semester, right? It was blue to green to yellow, right? Like the endpoint was green. So this is just a sort of good strategy to have in doing these titrations with, for a lack of better words, I guess, a less clean or distinct endpoint. I mean, the endpoint here is clean. It's purple to blue, but that's just harder to see, at least for me, than it is no color to faint pink, as in the case of phenolphthalein. So I'm going to do 2 more of these titrations using EDTA buffered at pH 10 with ammonia, and then using Ariachrome black tea as the indicator. If you want to watch the rest of this video, you can. If you want to watch me screw up a titration, I think I mess up like the 3rd or 4th one. But if not, watch the other video where I do the titrations involving now. In those titrations, it'll be sodium hydroxide to drive the pH up, and we won't use Ariachrome black tea anymore. We'll instead use a indicator called hydroxynaphthol blue. Ariachrome black tea doesn't work in the pH range of the 2nd titration. And by doesn't work, I mean we won't see the expected color change like we will in this video. So we use hydroxynaphthol blue, which does work in that pH range, to get us a more achievable endpoint, right? But yeah, so if you want to stop watching the video at this point, feel free. If you want to keep watching me do 2 more titrations and potentially screw one of them up, feel free to keep watching. Right, so I'm still employing good technique here. I'm going slow. I have both hands on the burette pretty frequently. I think I'm getting close to the endpoint, so I have one hand on the stopcock to close it as I need, and one hand is swirling to make sure that anything that I do add is mixing thoroughly. There's that purple starting to show up. And I think this is almost blue, so let's compare. It's almost there. Really close. Not quite, though. Still definitely has a bit of a purple hue to it. Almost there. Here I let out a part of a drop. Tap it to the side, rinse the flask down, because I think I'm getting really close to the endpoint of this titration. Still a little purple. Again, a smidge of a drop. Tap it to the side, rinse it in. Give this thing a swirl. Still a little purple, one more fraction of a drop, trying to, right, so my first titration was rough, but it wasn't, that rough, and so I'm using that to sort of guide my endpoint of this titration. Still close. Think of this as the final fraction of a drop that I add. Notice I'm glancing over to the right to see the titrations that I've already done to compare the color. I think this is it. So bring up the previous 2. Looks great. Record my volume and move on to the final titration. Right. So in this titration, the data that I'm collecting is just the volume of the EDTA solution, and this EDTA in this titration is reacting with both calcium and magnesium ions that are present in solution. In EDTA titrations, right, because as Dr. Vaita has talked about in lecture, it's really good at reacting with a whole bunch of different metal ions, right? So when you do EDTA titrations, it's very common that you do a blank titration where you just perform the titration, but instead of using your sample, you do it with deionized water, right? To just ensure that, hey, the deionized water that I'm using for this lab isn't interfering with my titration, right? Because obviously if the deionized water has group 2 elements in it or other things that can react with the EDTA, then it's going to skew your results. You do a blank titration to account for that, right? I did do a blank titration in this. The deionized water from the get-go was blue, so we don't have to worry about accounting for any ions in our deionized water sample, which is good. It's deionized water. It shouldn't have stuff in it that isn't water. But sometimes it does. I've done this lab in the past and had issues where, well, I stumbled upon the fact that our deionized water system wasn't working one year, so that was fun. So last titration here, already getting that purple to show up. So close, not there yet. So I'm going to do a few more, I think, fractions of drops. My hand accidentally slips and I let a full drop in, but it didn't get me to the end point, which is good, thankfully, luckily. So part of a drop, tap it, rinse it in. I think I do this once or two more times. Pull up one of my previous titrations to compare. Still got a bit of a purple hue. Bit of a dropout, tap it to the side, rinse it in. And this looks good, I think. Yep, recording my ending volume and then done with the first set of titrations here. So I guess I'm not sure, so I'm letting the sample sort of sit, the titration sit, calm down, let a drop land in. So the previous, I didn't see a color change, so the previous titration, or a burette volume that I had read was good. All right, cool. So clean it up. So yeah, go watch the other video where I do the second set of titrations where we add sodium hydroxide instead of ammonia, and I use hydroxynaphthyl blue as the indicator instead of Ariachrome black tea. But yeah, thanks for watching.